for the problem 1, we are given that the density function of fx is equals to this formula, and the density function of fy respect to y is equals to this formula. And we are given that z is equals variable x plus y, so y is equals to negative x plus z, and we need to find the distribution function and density function of fz. And first we apply the convolutional method, so we just apply the formula of convolutional, and we plug in the equation of fx and fy. Here times. So we plug in the formula of fx and fy. We get this is fx, and this is fyz minus alpha. And we expand this term, we get here we should times u z minus 1, and we get this z minus 1 is from the integral upper limit minus integral down limit. And similarly, we get our other terms. Here we times u z minus 3. Here we times u z minus 2, and the final term is z minus 2. And so after calculation, we get our final result equals to z minus 1 times u z minus 1 plus z minus 3 times u z minus 3 minus 2 times z minus 2 times u z minus 2. So here is the answer we get from the convolutional method. And next we will continue, we will redo this problem with the geometry method. And since we know that fx and fy is equals to this representation, if we can kind of draw fx and y in the same plane, it should be this area. And we know that z is equals to x plus y, so y is equals to negative x plus z, so y should be this straight line with slope as negative 1. And here I redraw it in the next plane. This is the joint distribution of fxy, and this is the different case of y equals to negative x plus z. So here we first calculate the density function of fz, f capital Z, it is the probability that x plus y smaller than z. So it should be the area under the purple curve. So here we have mainly 4 cases. The first one is that when the line is at here, here we can see that the overlap area of the area below this purple line and the area of fxy is 0. So in this case, we got our capital Fz equals to 0. So take the derivative, the density function of Fz is also equals to 0. This is for 0 between, this is for z between 0 and 1. And the second case is that the line is at here. So we can see easily that the overlap area should be this red area. So the density function of Fz equals to this red area. It is equals to 0.5 times z minus 1 the power of 2, and take the derivative, we get our density function of Fz equals to z minus 1. This is for z is from 1 to 2. And the third case is that the purple line stated here. So in this case, the red area is our final answer, and the yellow area we can calculate it is equal to 1 minus this small triangle, right? And this is equals to this formula. So take the derivative, we get our density function of Fz is equals to 3 minus z. This is for z is from 2 to 3. And for the last case is that the line is stated here, and this is 3 case. The last case, we can know that the density function is 1 because all the white area is below this purple line. This is the density function of Fz is equals to 1. The distribution function of Fz is equals to 1. So take the derivative, the density function of Fz is equals to 0. This is for the greater than 3. This is yeah. This actually it's I need to correct that it should be z from 0 to 1. It should be z smaller than 1. Yes. And we get this formula, and it is corresponding with what we get when we use the convolutional method here. These actually they are the same.